I'm going to talk about dilations and scale factor. So we've already talked about the fact that a dilation is something that either gets larger or smaller. So there's a couple pictures of that. You guys have this printable, so just follow along as I go through it with you. It says, Harold and his friends went to a wizard camp where they took a class on spells and potions. The group tried several potions that would either cause you to grow or shrink based on the scale factor of the potion. Fill out the table below to show the effect that the potions had on Harold and his friends. You'll see the first one is done for you. The starting height was 60 inches. The scale factor of the potion was 1/2. So the process is just multiply 60 by 1/2, and you'll turn into 30 inches, which is obviously shrinking. I'll do one more with you guys. 64 inches, the scale factor is 3, so I'm going to do 64 times 3 with my trusty calculator, and I've got 192 inches, which is obviously growing and making them larger. So at this point, I'd like you to pause the video and try working out the rest of that table. All right, so this is hopefully what you got for 56 inches and a scale factor of 1/8. The new height is 7 inches, which is shrinking. 58 inches, scale factor 2.5 is 145 inches, which is growing. And then 60 inches with a scale factor of 0.4 becomes 24 inches, which is shrinking. And then 62 inches with a scale factor of 3/2 is 93 inches for the new height, which is growing. You've got 4 follow-up questions to that. First, just describe in your own words how you calculated the new height after each potion. So you can look at the process there and you can see they all used multiplication. So maybe just jotting down, multiply the starting height by the scale factor. And then the next 2 questions are really the ones I want to kind of hone in on. It says, list the scale factors that caused Harold and his friends to grow. And what do you notice about that list? And then list the scale factors that caused Harold and his friends to shrink. And what do you notice? So I'm going to go back up to my table and I'm going to highlight the scale factors that made them grow. So maybe make that list 3, 2.5, and 3/2, and anything you notice about them. And then let's do the same thing for shrinking. So shrinking was 1/2, 1/8, and 0.4. And notice 2 of those are fractions and 1 is a decimal, and I could write that decimal as a fraction. Let's see if there's anything else you notice. And then the last follow-up question says, what do you think would happen if someone drank a potion with a scale factor of 1? So thinking about that process, if the scale factor was 1, what would happen? So kind of jot something down there real quickly. All right, so scale factor is a ratio of the corresponding sides in a figure. We're always going to put the new figure over the original figure or the image over the pre-image. Remember, image is your new figure, pre-image is your original. So hopefully this is what you noticed in those follow-up questions. If the scale factor is greater than 1, it will enlarge the figure. And if the scale factor is less than 1, it will reduce the figure. A dilation is a transformation that either enlarges or reduces the size of an original figure. In order to dilate the figure, you're going to do what we just did with that table up above, and you just simply multiply by the scale factor, okay? So key is we're going to do lots of multiplication. So I've got 5 questions for you guys. The first 3, you're given the scale factor, and you're asked to dilate each rectangle by that scale factor and record the new dimensions. Now remember, if our scale factor is less than 1, then our rectangle is going to reduce in size. It's going to get smaller. So 15 inches will get smaller and 35 inches will get smaller. You guys are welcome to use a calculator and type in 15 times 2/5. Okay, I want to remind you guys, when you're multiplying with fractions, you can just go straight across the top, 15 times 2, and straight across the bottom, 1 times 5, and then reduce or divide 30 by 5 and get 6. You can, however, when you're working with fractions, if you recognize something in the numerator and denominator that will simplify first because they have a common factor, we can do that. So I notice 15 and 5 have a common factor of 5. When I divide by 5, it simplifies to this. And now I'm just multiplying 3 times 2 and getting that same 6 because my denominators are both 1. So I can do this just as easily without a calculator as you can with a calculator. Again, I don't mind you using a calculator. So 35 times my scale factor of 2/5. I'm going to simplify first again, so I'm dividing 5 by 5 and 35 by 5. And so now I have 7 times 2 on the top is 14. My denominators are both 1. I don't need to write that it's over 1. So my new rectangle is 6 inches by 14 inches. I want you guys to try number 6 and 7 on your own. I'll give you a hint and get you started on number 6 and remind you that 3.5 is greater than 1. So this rectangle should get bigger. So go ahead and pause the video. All right, so hopefully what you did is 10 times 3.5, which is 35, and 22 times 3.5 with my trusty calculator is 77. So I have a 35-inch by 77-inch rectangle. And then on number 7, again, the scale factor is greater than 1. And when you multiply both of those side lengths by 5/3, I'm sorry, it's 5/3 is the scale factor, you'll get new dimensions of 40 inches by 50 inches. And again, that's by taking 24 over 1 times 5/3, or just 24 times 5/3 with your calculator, and 30 times 5/3 with your calculator. All right, 8 and 9, we now have the new and the old dimensions, and we're asked to find what was the scale factor used to create the new figure. So first is understanding which one's your pre-image and your image. So we're going back to the first triangle just has GHI. The second triangle is the one that has the primes on it. Remember those little prime marks? I'll make them a little bit bigger. So this one is my image or my new figure. And the smaller one is my pre-image or my original figure. So remember, if we back up to those notes for just a second, we're gonna go new over original or image over pre-image, whichever words you wanna use. And we are matching up corresponding sides when I do that. So if I pick this 10 right here, it corresponds to this 8. So 10 over 8 is 5/4 or 1.25, which is good because my triangle got larger, so I needed a scale factor greater than 1. If I decide instead of using those two sides, I want to use these bottom sides, I've got 15 over 12. That is also equal to 5/4 or 1.25. So my scale factor is 5 over 4 or 1.25. Scale factor does not get a label on it. It's just a numerical value. It's what we use to multiply by to get the new figure. So if I go back here and I say what happened to my pre-image to get to my image, I can say everything multiplied, all the side lengths, I'll clarify that, all the side lengths multiplied by 1.25 to create a similar triangle. All right, y'all pause the video real quick and try number 9. Okay, for number 9, if I'm matching up, again, corresponding sides, this time my image got smaller, so I'm going to get a scale factor less than 1. I'm going to match up this 12 with this 18. Or I can match up this 8 with this 12. Either way I look at it, those are equivalent to each other and give me a scale factor of 2/3. You'll notice I'm not going to go to a decimal on this one because it's a repeating decimal. So please do not give me repeating decimals for scale factors. I much prefer the fraction. And again, this pre-image was reduced in size, and so my scale factor should be and is less than 1. If you ever get a scale factor that you know is not right, like it's supposed to be less than 1, but your scale factor is greater than 1, more than likely you're upside down on your scale factor. So if you'll just do the reciprocal of your scale factor, that will probably fix it. All right, here's what you guys are going to work on now. You've got one assignment that goes along with this. You have the printable available to you if you want to use it, but it is on Go Formative. So 3.5.3, scale factor and dilations, Go Formative. If you want the printable, this is what it looks like. If you want to work it out on paper first, feel free to do so. Make sure you put your answers in the Go Formative for me. And then after doing that, I have another video that I want you to watch before we meet again. It talks about doing dilations on a coordinate plane, much like we did with our translations, reflections, and rotations last week. The printables that you have for this are not going to go along with the video exactly like blank by blank, but you will get the information in the video that you need in order to fill in the blanks. So do the best you can with that. We will do examples together in class next time. I just want you to watch the video and take notes for homework.